How did you go? Okay, here are the work solutions to those 4 exercises. This first one is ASCII1.c, and it's very straightforward. Please enter your full name. Now, you might recall that this was actually the example that I showed you earlier in the chapter, and there was this little exercise here on removing the new line. I'd like to show you how to remove the new line without using a variable called len. Is that possible? Let's try it. In fact, without using any variables. So I want to get rid of this one, like that. Now I'm going to take that strlen and I'm going to put it right there where the len was. What do you think about that? So we're using an array index. This whole thing is an array index, but it's also the results of a function. Now, just all I want you to do is notice that that is possible, that stuff actually works. It's okay to do that, so we don't need the len variable anymore. Okay. So anyway, here's the actual guts of it. For each character in the name, or in the name that they typed in other words, we're going to walk along the string using a for loop until we get to a null character, which will probably be this one if there was a new line entered. Simply print out the decimal representation of the character name I. Now remember that name I is an array of characters, but we're printing out a %d. Okay, and then here's a little cheating thing, put a new line on the end. It certainly doesn't look like we're putting a new line. That is actually a pair of double quotes with nothing between them. In other words, it's the empty string. So there's no characters in that string at all except a null character to terminate it. So it's a 1-character string. But remember, when you use putS, it actually puts a new line on the end of whatever string you're outputting. So we'll output nothing, and then putS will put a new line there as well. So the whole thing actually puts a new line on the end of all of that. Okay, let's test it, see if it works. Okay, compiles, run, mark virtue, and what output do we get? Whoa, okay, well there's a bunch of numbers. Let's see, we know that A is 97, so there's an A, and there's a 97. That's very nice. Okay, so it's actually ripped off the new line because I told it to, so I don't mind if yours leaves it in, and you'll see a new line there as well. There's a space character. Space character is 32, which happens to be 20 in hex. Okay, so that's working. Let's move on. This is ASCII2.c. This displays the ASCII character set. Now, you may have had some troubles with this, finding out which characters were the special ones. Anyway, let's have a look at it. The ASCII character set, and we're going to print from 0 to 256, or from 0 to 255, which is 256 characters. Now, notice that this is an integer. I could have said char there, but that would not work. And I'll tell you why it wouldn't work. Well, it's a bit tricky. It's a bit tricky to explain, but see if you can bear with me here. Char, the actual data type char, can only possibly have 256 different numbers in it, and they go from 0 to 255. Well, technically they go from -128 to 127, but for the purposes of this discussion, pretend that they go from 0 to 255. So we're going to start with 0 and keep adding 1, and we'll get to 255 and go through and do all the stuff that we need to do for 255. Then we'll come back and we'll add 1, won't we? We'll add 1 to a number that's already the largest number that it can possibly be. So what happens? What happens when you add a number to the number that's already the largest it can be? Well, if you don't know, it actually wraps back round to the lowest number that it can possibly be, which in this case is 0. So it'll wrap back around to 0. So 255 plus 1 is 0. So now we'll go back to here and we'll find that this is 0 again, and this condition is true. So we'll keep going in the loop. In fact, we'll never be able to get out of the loop because I can never possibly be greater than or equal to 256, because I is only a char, and chars can never be greater than or equal to 256. Okay, did you understand that? Hope so. Let's move on. Now, I'm going to make sure the special characters are not printed. In place of them, I'm just going to print a space, just to make it look nice. Okay, and here are all the special characters. There's all the ones that are mentioned in the C reference manuals. There's another one actually called the bell character. I don't know if any of you have actually noticed this, but when you print out your output, your computer makes a little beep or a little ding or something like that to indicate that the bell character got printed. And it's funny, there is a bell character. I think it's character number 7 from memory. When you print it out, your computer actually makes a noise. How can that be? Well, it just is. Just learn it and know it. Now, I don't know what these two are, but they certainly screw up the output, so I've just made sure that I don't print those out as well. Instead, I'm going to print out a space, or in fact 2 spaces, because I want to put a space between every character. And then, if it's not any of those characters, then I use this, which I simply print out the actual character represented by the integer I, which is fair enough. That's the whole point of the exercise. That's what we're trying to achieve. Now notice I use a switch statement here and not a series of ifs. I could say if I equals n, or I equals r, or I equals t, or I equals f, or I equals b, or I equals v, or I equals 26, or I equals 27. Now that's a very long if statement, probably be quite cumbersome to write. This is much neater to write, as you'll notice if you tried that. And you'll also find, this is something you can just know about C, that using a switch statement for this sort of thing is actually much more efficient. The code will run much faster. See if you can figure out why in your own time. Okay, so we print out the 2 characters. Now, after every 16 characters, print out a new line. How do I know if I've printed out 16? Well, I take my loop counter and essentially divide it by 16 and see if I get a remainder of 0. And if I do, it must be divisible by 16. Obviously we're going from 0 to 15 because, well, we're starting with 0, so we don't want to mess that up too much, so we'll just add 1 to that. And if so, put out a new line, which is the clever way that I did it in the last exercise. And that's pretty much it. Let's run it and see what it looks like. Compile. Okay, and run. The ASCII character set. Now there's a few characters missing. It's characters 7, 8, 9, 10 and 11 I think are all missing from there, and 26 and 27 are missing in here somewhere as well. That's not entirely perfect, is it? No, that's slightly out. Well, I'll leave that as an advanced exercise for you to figure out how to fix that, but it doesn't look too bad. And you'll notice that all these unprintable characters are actually printable. Well, they're printable in some sense. If you just tried printing out just the printable characters, you wouldn't get this set of characters, because these ones down here are classified unprintable. Anyway, that's what it looks like. Let's move on. This is convert.c to convert a person's name to uppercase, title case, etc. Okay, so enter the name, pretty straightforward. Remove the new line, as we did in that clever way before. Convert to uppercase. Now that's as simple as can be, as you can see. Walk along the string with for loop until you get to a null character, and take that character, run it through toUpper and put it back into the same character. I know a lot of you might have printed out the character at that point. Rather than converting it, you would have just printed out toUpper of name I. That's okay, although this way of doing it is a little bit more flexible because the string actually changes, so we actually have converted the string itself, as opposed to just printing out what the string would look like if it was converted. Okay, show the results. That will give the answer with a new line on the end. Now, title case. Title case is a bit tricky because you have to make sure that you remember where you were along the string. If you've just encountered a space or a blank in the text, then the very next character has to be converted to an uppercase. But if the last character was not a blank, then you just make sure it's lowercase. You have to convert it down to lowercase if necessary. So we need a Boolean variable, and this is the Boolean variable here. And it says, it essentially is a true or false thing. The last char was a space. Now you don't have to do it that way. What you could do is simply keep track of the last character. You could have a variable here called last char. Now that would work, but this way will work as well. We'll do a little flag. Now we have to make sure that that is immediately set to true. We have to pretend there is no last character because we haven't started reading the text yet. But we have to pretend that the last character was a space, so that the very first character that we output gets put as a capital. So there's a little trick there, a little initialization. Anyway, walk along the string in exactly the same way that we walked along the string up here. And if we see a blank, we're going to do this code first. If we see a space of any kind, then we set the flag to say that we've seen a blank, and we just simply move on. There's nothing else to do. There's no conversion required. And we go and do the next the next character in the string. Now, if we get down as far as here, we don't have to use an else because we use this continue here. I'll say that again. We don't have to use an else here. We don't have to put that there because we've got a continue there. Now, if you don't believe me, see if you can figure out why that's the case. I'll leave that with you. But I assure you that it is the case. We do not need an else. If we get to here, then we couldn't possibly have anything but something that's not a space. So now we'll check to see what the last character was. If the last character was a space, then convert the current character to uppercase. Otherwise, convert the current character to lowercase. And obviously make sure we don't forget this bit, which is to say that this character is not a space. Okay, that's all there is to it. Again, just print out the output. Let's compile that and run it. Please enter your name, Mark Virtue. Okay, I'd like to try that again. This time I'll mix up the case a bit. M-A-R-K-V-I-R-T-U-E. Now that looks really wrong. Let's see if it fixes that up. Isn't that lovely? Okay, excellent. That's done. Now let's go and look at the course project, which is pretty straightforward. Here's the course project again. The changes to this are very straightforward, much easier than the exercises, so let's just go and have a look at a few of them. There's a couple of there's a couple of put s's. Okay, there's an f put s there because we didn't want to have a new line on the end of a question. We use a scanf there. I could have used a get s, but I would have had to read it into a string and then just examine the first character of that string, and I didn't really feel like doing that. Notice that I'm just simply doing this now. If the type converted to uppercase is a capital Y, then we break. Otherwise we don't. And put out a new line. Again, in that clever way. We've got an f put s there, we've got an f get s there. Now notice that the string that we're actually reading is that string. That is one string. Remember, this is a two-dimensional array, or an array of strings. Now I've done something clever here. That's the simple part of fgetS. Remember now, at this point, that text has to represent how big the array is, how many characters it is. So I'm going to use this clever thing in C called sizeof. You haven't seen sizeof yet. We'll actually have a look at sizeof in more detail in the next chapter. Sizeof just simply tells you how big in bytes the thing to its immediate right is. So the thing to its immediate right is that. That is an array. So this thing tells you how big that array is in bytes, which is exactly what we want. So what we don't have to do is we don't have to go and say, oh, how big was it? Scroll up, scroll up, scroll up. Oh, it was 61 characters. Oh, okay, back down again. There it is, type 61. I tell you why. The biggest, it's not just for saving time. It's a maintenance issue. Because if you ever go and say to yourself, oh, hang on, that's 61, that's not right. We need more space than that. We need 81 or 101, or we need less space than that. We need only 21, and you change it, like you make that change, and you say, okay, I'm done now. Guess what? You're not done. Especially like in that example, if you make it less, because if we go back down here, and this just, oops, sorry, it's here. If this just happened to be, if this code actually said 61, like that, and you went up the top and changed it to 21, you'd probably crash your program. And you'd have to remember to come back here, and it would take you a long time, and you'd get frustrated. So it's much easier to do that, which means if you change it up the top, it automatically changes here as well. I hope you can see the benefit to that. Okay, so that's an fgetS. And I decided that it would be nice to remove the new line. Now, I removed the new line exactly the same way as I removed the new line before, with that clever bit of code that you saw in the last episode, in the last module, in the last exercise. There, that's the word. So, This is one string. So notice that I've got an open close bracket, then I've got an open close bracket there. Now I want you to just stare at that code until you get it, because it is exactly the same as the way that I removed the new line in the last exercise. This is the string, and this is the string. If you remember that, then you can figure it out. I promise you can. It doesn't need any further explanation because we already know what two-dimensional arrays look like and how to reference them. Okay, so exactly the same stuff with the artist. The stuff with the tracks hasn't much changed, except I've done a fputs here instead of a printf. Again, fputs here, and here I do a little clever conversion to uppercase of the answer that they typed in, and then I compare it with uppercase A or uppercase S. Think about it. I'm sure you'll agree that's right. And again, don't forget this one as well. Make sure that's an uppercase A. And the rest of it's all pretty much the same. Blah blah blah. The odd put S can be used here when we're not doing anything clever. We're not using any %Ds or %Ss, so I can just use put S because it's faster. There's another one there, another one there, another one there, another one there, and that's it. Pretty simple. I told you it was simple.